Welcome to episode 47, Hybrid and Multicloud, When and Why. The terms hybrid cloud and multi-cloud are often used together, but they describe different strategies for balancing flexibility, control, and risk. A hybrid cloud integrates on-premises infrastructure with one or more public clouds, creating a single environment that spans both. Multi-cloud means using multiple cloud providers, sometimes for redundancy, sometimes for best-of-breed capabilities. Both approaches address complex realities, legacy systems that cannot easily move, regional data restrictions, or specialized workloads that perform better in certain clouds. For leaders, the key question is not which model sounds modern, but which aligns best with operational goals and business outcomes. Hybrid and multi-cloud architectures offer freedom, but they also introduce management challenges that require thoughtful planning and governance. The business drivers behind these models usually revolve around risk management, resilience, and strategic negotiation. Risk management comes from avoiding dependence on a single vendor, ensuring continuity if one provider faces disruption. Resilience improves because workloads can fail over between environments, keeping services available even during outages. Negotiation leverage also increases when organizations can shift or replicate workloads across providers, encouraging competitive pricing and innovation. For example, a global retailer might distribute its e-commerce platform across two clouds to avoid downtime during seasonal peaks. These strategies are not about spreading systems everywhere, but about maintaining optionality and resilience in a dynamic marketplace. Hybrid and multi-cloud decisions must always start with clear business reasoning rather than technical curiosity. Regulatory constraints and data sovereignty requirements often make hybrid or multi-cloud architectures unavoidable. Many governments and industries restrict how and where data may be stored or processed. Health records, financial data, and personal identifiers may need to remain within specific borders. Hybrid deployments let organizations keep sensitive workloads on-premises or in regional data centers while still taking advantage of public cloud scalability. For example, a healthcare provider might store patient data locally while using the cloud for anonymized analytics. Similarly, multi-cloud arrangements can support compliance by distributing workloads across providers that meet local certifications. The architecture becomes not only a technical solution, but a compliance framework that allows global operations without violating local laws. Latency and locality shape user experience and are major considerations in distributed architectures. Users expect fast response times, and even small delays can reduce engagement or conversion rates. Hybrid environments help by placing data or compute resources closer to end users, reducing round-trip times. For instance, a gaming company might run its global matchmaking service in the cloud, but keep latency-sensitive game servers near player regions. Multi-cloud strategies can also improve performance by deploying services through providers with strong regional presence. The result is better responsiveness and resilience, even under varying traffic conditions. Understanding where users are and how they interact with applications is critical when designing hybrid or multi-cloud topologies that deliver smooth, consistent experiences. Existing investments in workforce skills often determine whether hybrid or multi-cloud approaches make sense. Organizations that have spent years developing expertise in particular platforms or maintaining on-premises systems may not want to discard that knowledge. Hybrid models allow them to extend existing infrastructure into the cloud without starting from scratch. Multi-cloud flexibility also lets teams experiment with new tools while maintaining familiar ones. For example, an enterprise might continue using its on-premises databases while deploying new API services in Google Cloud or another provider. Aligning architecture with team strengths reduces friction, lowers risk, and ensures that adoption happens at a sustainable pace. Cloud strategy should build on institutional capability, not ignore it. Consistent identity and policy enforcement become crucial when systems span multiple environments. Users and services must authenticate securely regardless of where they operate. A unified identity model, using centralized authentication or single sign-on, simplifies access control and compliance tracking. Policy enforcement must be equally consistent, applying the same rules for data classification, encryption, and network access across clouds. Without that consistency, visibility fragments and security gaps appear. For instance, if one cloud enforces stronger password policies or token expirations than another, attackers might exploit the weaker point. Using federated identity providers, shared policy engines, and centralized logging maintains coherence. This cross-environment identity discipline is what turns hybrid and multi-cloud setups into governed ecosystems rather than accidental patchworks. Networking underpins all hybrid and multi-cloud operations, and its design determines reliability and performance. Interconnects, VPNs, and private peering links allow secure and low-latency communication between environments. Routing must be planned to balance cost and efficiency, avoiding unnecessary data transfers that increase expenses. For example, an enterprise might use dedicated interconnects for steady, high-volume traffic and public internet paths for less sensitive workloads. Segmenting networks with clear zones also limits risk. If a breach occurs in one cloud, it should not propagate to another. Proper design includes redundancy, failover, and monitoring. In practice, networking complexity often dictates whether hybrid or multi-cloud models succeed. Leaders must treat connectivity as a first-class design problem rather than an afterthought. Tooling portability determines how easily teams can move or replicate workloads across providers. Containers play a major role here because they package applications in a portable way, independent of underlying infrastructure. Standardized interfaces, like Kubernetes APIs, allow similar deployment practices across environments. Cloud-agnostic tools for monitoring, automation, and configuration management further reduce lock-in. For example, using Terraform for infrastructure as code enables the same deployment scripts to work across clouds with minor adjustments. Industry standards such as OpenTelemetry for observability or OIDC for identity reinforce portability. Building around these open tools ensures that the organization's operational model remains consistent, no matter where workloads run. Operational complexity is an unavoidable side effect of hybrid and multi-cloud architectures. Managing multiple platforms means multiple dashboards, billing systems, and security controls. Each cloud provider evolves independently, introducing new features that must be learned and integrated. These layers of variation create hidden overhead in training, governance, and troubleshooting. Without strong automation and documentation, operations teams risk burnout or errors. For example, inconsistent tagging or resource naming across clouds can make cost reports unreliable. Leaders should recognize that complexity carries real cost and should plan accordingly by investing in standardization, orchestration, and cross-team knowledge sharing. Simplifying wherever possible is key to long-term sustainability. Cost modeling across hybrid and multi-cloud setups requires careful attention. Different providers have unique pricing structures for compute, storage, and data transfer. Moving data between clouds can be surprisingly expensive, particularly when traffic crosses regions. Hidden costs also appear in operational tooling, redundant services, and staff training. A comprehensive cost model should include both technical and human factors. For instance, an application spanning multiple clouds might incur performance benefits but double its networking fees. Using unified billing analysis tools helps maintain visibility, while periodic reviews keep usage aligned with budget. Cost optimization in multi-cloud environments is an ongoing discipline, not a one-time calculation. Exit strategies and portability guardrails protect organizations from vendor lock-in. Every deployment should include a clear plan for migrating data, configurations, and workloads if business or regulatory needs change. This might mean maintaining data exports in standard formats or using abstraction layers to avoid deep dependencies on proprietary services. For example, a company using managed databases should regularly test its ability to back up and restore data on alternate platforms. These guardrails keep options open, reinforcing negotiation leverage and strategic resilience. Without them, a hybrid or multi-cloud strategy can turn into a complex trap that is harder to exit than the single provider model it replaced. Governance keeps hybrid and multi-cloud ecosystems coordinated and compliant. Ownership structures define who manages which systems and who resolves incidents. Runbooks document standard operating procedures for maintenance and escalation. Compliance teams verify that each environment adheres to policies on encryption, privacy, and auditability. Centralized oversight tools can track resource inventories and detect drift between configurations. For example, a financial institution operating across two clouds might have a governance board that reviews changes to ensure consistent risk management. Governance is not about restricting innovation, but about ensuring that innovation happens safely and predictably. Without it, hybrid and multi-cloud operations can quickly drift into chaos. Phased adoption provides a structured way to implement hybrid or multi-cloud strategies with measurable milestones. Starting small, perhaps by moving one service or region, allows teams to learn before scaling. Each phase should include clear success metrics, such as latency improvement, cost reduction, or compliance validation. Lessons from early deployments feed into later expansions, creating a feedback loop of refinement. For instance, a company might begin with disaster recovery replication, then expand into active-active traffic distribution once confidence grows. Phased implementation prevents overreach and ensures that benefits are realized incrementally rather than promised abstractly. Leaders should treat hybrid and multi-cloud adoption as a journey guided by evidence, not by enthusiasm alone. Choosing outcomes, not ideology, is the hallmark of successful hybrid and multi-cloud strategies. These models are tools, not statements of technological loyalty. The goal is to achieve resilience, compliance, and agility that match the organization's realities. Some workloads thrive in tightly integrated hybrid setups. Others benefit from distributed multi-cloud diversity. The right approach depends on business priorities, technical capabilities, and risk tolerance. By focusing on measurable outcomes, availability, performance, and cost efficiency, leaders ensure that architecture decisions serve strategy rather than trend. Hybrid and multi-cloud done well deliver flexibility without chaos and innovation without losing control. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.